Dear children, it is a continuation of the chapter Force and Laws of Motion. Now let us solve the in-text questions. The first question is, if action is always equal to the reaction, explain how a horse can pull a cart. So, what will be the answer here? To pull the cart, horse pushes the ground with its foot in the backward direction by pressing the ground. As a reaction of this force, the ground pushes the horse in forward direction. That is due to which the horse pulls the cart. So, here action is the pushing by the horse on the ground in the backward direction, and reaction is the pushing from the ground in the forward direction, that is on the horse. So you write the answer. To pull the cart, horse pushes the ground pushes the ground with its foot in the backward direction by pressing the ground. Foot in the backward direction by pressing the ground. By pressing a ground, it is a reaction. It is a action. As a reaction of this force, the ground pushes the horse. The ground pushes the horse in forward direction. Due to which the horse pulls the cart. Due to which the horse pulls the cart. So, if action is always equal to the reaction, explain how horse can pull a cart. Here the action is, that is the force exerted by the horse, that is in the form of pushing the ground with its foot in the backward direction. That is by pressing the ground. And its reaction is the ground pushes the horse in forward direction and the horse pulls the cart. The second question is, explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. Explain why is it difficult for a fireman to hold a hose which ejects large amount of water at a high velocity. A fireman finds it difficult to hold a hose pipe which is ejecting large amount of water at high velocity, because the stream of water rushing out of the pipe in the forward direction exert a large force on the pipe. Due to the reaction of the forward force, a force is applied on the pipe in backward direction. Therefore, the fireman struggles to keep the hose pipe in rest. So, you write the answer that a fireman, right here, answer. A fireman finds it is difficult to, a fireman finds it difficult to hold a hose pipe, hold a hose pipe which is ejecting large amount of water at high velocity. Large amount of water at high velocity. High velocity, because the stream of water rushing out of the pipe in the forward direction exerts a large force on the pipe, due to the reaction of the forward force, a force is applied on the pipe. A force is applied on the pipe in backward direction. In backward reaction of the in the backward direction. Therefore, the fireman struggles to keep the hose pipe in rest. Therefore, the fireman struggles to keep the hose pipe in rest. Now the third question. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 ms to the power of -1, that is meter per second. Calculate the initial recoil velocity. Here, from a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of the 35 meter per second. So you write mass of gun. So you take the solution here. Mass of gun. Let us take it as capital M, that equals 4 kg. And mass of bullet. Mass of bullet mass of bullet let us have it is small letter m, that equals 50 gram. Here we have to convert this gram to the kg. You know that kg is the SI unit. Then you take, that is 50 divided by 1000, because 1000 grams equals 1 kg. Then it becomes kg equals 50 into, or this becomes 50 by 10 power 3 kg, that equals 50 into 10 power minus 3 kg, 10 raised to minus 3 kg. And the initial velocity of the bullet, let us have it is small v, that is after firing. So that is v equals 35 meter per second, that is ms to the power of -1. And what you have to find out? We have to find the recoil velocity of the gun. So you take, then recoil velocity of the gun, v equals question mark. So you take, let recoil velocity of gun equals capital V equals question mark, that is after the firing. Here you know that before the firing the bullet was inside the gun and the total momentum is equals to 0, as both bullet and gun were in rest. So before firing the bullet and the gun were at rest. The total momentum of gun and bullet is 0. And here after the firing, if you take U and U are the in before firing, right? Before firing both bullet and gun were at rest. Therefore, here you can have that, and let their initial velocity, before firing are let u, that is the, take that capital U and small u. Let capital U and small u. Here capital U is the velocity of the gun before firing, and u is the velocity of the bullet before firing. So that becomes here both are at rest means mv m not mv mu equals mu equals 0 means total momentum before the firing equals 0. So you take total momentum before firing equals mu plus small mu equals 0. That is the momentum of the gun is 0, momentum of the bullet is also 0, that is before firing. And after firing total momentum equals, so you write mv plus mv. This is the momentum of the gun after firing. This is the momentum of the bullet after firing. So you know that the total momentum before firing must be equals to total momentum after firing. So write total momentum before firing equals total momentum after firing. So total momentum before firing is mv plus mu. You take first here, so you write total momentum after firing equals total momentum before firing. So total momentum after firing is this one, mv plus m small letter v, and here you know that equals mv plus, that equals, you write capital mu plus small mu. This is the momentum of the gun after the firing. This is the momentum of the bullet after the firing. This is the momentum of the gun before firing. This is the momentum of the bullet before firing. So the total momentum after the firing must be equals to total momentum before the firing. Here u and u are the velocity before firing, and capital V and small v are the velocity after firing. So the total momentum after firing must be equals to total momentum before firing. You know that this is equals to 0. You got here. So you take this is first. Therefore you write here mv plus mv equals 0. That is from first. Now you write here what is given. Capital M is given, that is what? How much? 4 kg. You write 4 kg. 4 you write 4, and V we have to find out. V you write V only, 4V plus M, that is the mass of the bullet, this one 50 into 10 to the power of minus 3. So you take 50 into 10 to the power of minus 3 into U, that is the small v. Small v is the velocity of the bullet after firing, 35 you take. that is 35 equals 0. Now here we have to find v, that is the velocity of the bullet after velocity of the rifle, velocity of the gun after the firing, velocity of the gun or rifle after the firing. So you write 4v equals minus 50 into 10 to the power of minus 3 into 35. Here it is shifted to RHS, becomes minus. Then v equals minus 50 into 10 to the power of minus 3 into 35 by 4. That equals, you know that here you will get 2 2s are 2 25s are. Then you find the product of 35 and 25. 35 into 25, 25 5s are 125, 12, 25 3s are 75, 75 plus 12, 75 plus 12 becomes 87, so it becomes 875. So you got here 875 into 10 power minus 3 by 2. That equals, you can have 875 divided by 2. 2 4s are 8, 7 is remaining, 2 3s are 6, 1, 1 5 is remaining, 2 7s are 14, 1, if you put 0 here, 0.5s are. So you got 437.5 into 10 to the power of minus 3. Then it becomes 437.5, 10 power 3, you take it down, that becomes positive exponent that you have learnt in 8th standard. Then it becomes 437.5 by 1000, 10 power 3 is 1000. That equals, here you cancel this 0, shift this 3 digits to the left right side here, that becomes 0.4375 by 1000. You do not write here, that is cancelled as you this shifted to right side. Then it becomes 0.4375 ms to the power of minus 1. So you can write that equals what? That equals approximately it is 0.44, you can write. 375 is approximately equals to 400. So you can write 0.44 ms to the power of minus 1. Now the fourth question. Two objects of masses 100 gram and 200 gram. 100 gram and 200 gram are moving along the same line and direction with velocities 2 ms to the power of minus 1 and 1 ms to the power of minus 1 respectively. They collide, and after the collision, the first object moves at a velocity of 1.67 ms to the power of minus 1. Determine the velocity of the second object. Here, let us take m1 and m2 are the masses of two objects and they are moving along a straight line. So you take two objects. Now let us consider the masses of the two objects are m1 and m2. m1 and m2. So you write the solution here. Solution. Let m1 and m2 are the masses of two objects, and also let us have their velocities before the collision are u1 and u2. u1 and u2 are their velocity before collision and let us have after the collision their velocities are v1 and v2. v1 and v2 are their velocity after collision. After collision. Now you write here m1 equals. So m1 equals 100 gram. You convert that into kg. That becomes 100 by 1000 kg. That equals 0.1 kg. That is the SI unit here. And m2 equals 200 gram. That equals 200 by 1000 kg. That equals, you know that 2 by 10 you will get 0.2 kg. Here also 0 cancels, 1 by 10 that is nothing but 0.1 kg. 100 gram means 0.1 kg. 200 gram means 0.2 kg. As SI unit of the mass is kg, we have to convert that into kg. Then you write u1 and u2. Here this is u1, that is the velocity of the object, first object, and this is the velocity of the second object before the collision. So you write u1 equals, what is that, 2 ms to the power of minus 1, and u2 equals 1 ms to the power of minus 1, and here the first object moves 1.67 ms to the power of minus 1 after the collision. So that is the v1, velocity of the first object means v1. v1 equals how much? 1.67 ms to the power of minus 1. What we have to find out? The velocity of the second object after the collision we have to find out. Then you know that the total momentum before the collision equals total momentum after the collision. So you write total momentum after the collision equals total momentum before collision. That is total momentum after collision is mass into after velocity. That is m1 v1 plus m2 v2. After the collision velocity is v1 and v2. So you have to take m1 v1 plus m2 v2. So you write m1 v1 plus m2 v2. That equals total momentum before the collision is m1 u1 plus m2 u2. And you know m1 is 0.1 and v1 is 1.67 plus m2 0.2, v2 we have to find out. That equals m1 again same 0.1 and u1 is 2 plus m2 0.2, u2 is 1. u2 is 1 here. u2 is 1 we have taken here, and u1 is 2 ms to the power of minus 1 we have taken here, and m1 is 0.1, m2 is 0.2. Here v2 is not given, we have to find v2. Then the product of these two, 1.67 into 0.1, you know that 167, that is adds up here, that becomes 0.167. 1.67 into 0.1 is 0.167 plus 0.2 v2, and 0.1 into 2 is 0.2 plus 0.2 into 1 is again 0.2. Then it becomes 0.167 plus 0.2 V2 and 0.2 plus 0.2, that you know that 0.2 plus 0.2 you will get 0.4. So you write 0.4. Now you transfer this to the RHS, that this 0.2 V2 remains in the LHS. So you write 0.2 V2 and you transfer that. That becomes 0.4 minus 0.167. That is 0.167. So you write 0.2 V2 and you subtract 0.4 minus 0.167, means here it is put 20. If you subtract, it becomes 10 minus 7 is 3 and 9 minus 6 3, 4 minus 1 3.0. So it becomes 0.333. Then V2 equals 0.333 by 0.2. So you remove one decimal point, it becomes 3.33 by 2. Then you divide 3.33 by 2, 3.33 by 2. So 2 ones are 2, 3 minus 1 2, take this 3 point put here, 2 6 are 12, 1 is remaining, again 3, 2 6 are 12, 1 is remaining, then again it is 5. So you got that equals 1.665. You know that the unit is here ms to the power of minus 1. So you got that 1.665 ms to the power of minus 1. That is the V2. Then what is the velocity of the second object after the collision? Determine the velocity of the second object after the collision is, that is 1.665 ms to the power of minus 1. Therefore you write, therefore the velocity of the second object after the collision is 1.665 ms to the power of minus 1. The velocity of the second object after the collision is 1.665 ms to the power of minus 1.